So now we are looking at question 5, which is, can say here that, this is our question 5. What is question 5 saying now? Find the value of a that makes the following function differentiable for all x values. Okay, so differentiable for all x values. So whenever you see this word differentiable, you should not panic, okay? When you see the word differentiable, we're just going to test two things. Number one, differentiable functions should be continuous, so of course we'll test that. And then also, their derivatives, when you put in this value, because their derivatives when you put in this value 0 must be the same. Okay, just like for continuity, we are going to check continuity around here. That's where we check differentiability as well. So because if their derivatives are not the same, that means it will have a cusp, which means it's not differentiable. Okay, which is either like that or like that. So now let's do number 5 and let's see. So we say when x is less than 0, we can put to say when x is less than 0, then we would have our g of x is going to be equal to ax. Okay, which means that the g dash of x, the first derivative of x, is just going to be equal to a. Then now we can say that the first derivative of 0 is going to be equal to a as well. If we put, because there is no x, so that's what happens. Then we can now say that when x is greater than or equal to 0, then g of x is going to be equal to x squared minus 3x, which means that the first derivative now is going to be, we drop down the power to reduce it by 1, becomes 2x. Then the derivative of negative 3x is just negative 3. And now we put this value, which we are at, g dash of 0 is going to be 2 by 0, then minus 3, which is going to be 2 by 0 is 0 minus 3, which is negative 3. So here we have it as negative 3. So now we can say for differentiability, since we already can find the solution, we can say for differentiability, we can now say that let this one, the derivative when x is less than 0 be equal to the derivative when x is greater than or equal to 0. Okay, so you can say a be equal to negative 3. For differentiability, you can say a, you can say let g prime of 0 when x is less than or equal to, when x is less than 0 be equal to g prime of 0 when x is greater than 0. Okay, which is going to be a is going to be negative 3, and this is your final solution. All right, that's what you have. A will be negative 3 basically, and you'd be done. That's the value for a, and you're done.